Okay, so in this video, I'm going to go through all the different types of calculation questions that come up in the course. There are quite a few calculations, so this video will be a little bit longer than the others. I just want to point something out. As we go through the different types of calculations, I'm going to be telling you to pause the video and practice some questions. It's so important that you do that. Okay, if you just listen to this video or have it on in the background, you're not going to learn anything. It's really important that as I go through each type of calculation, you pause, you do some questions for yourself, and then you mark it before moving on. Okay, to get good at calculations, you need to practice doing them. The first type we're going to look at is just calculating relative formula mass, which would have been the first thing that we did. And as the name suggests, you're getting the mass of the elements in the formula. And we can abbreviate relative formula mass to MR, which is how I always abbreviate it. Okay, so the example that I do for you in your revision booklet is I take K2O. Okay, so that's my chemical formula. And when I read my chemical formula, okay, K is potassium, and there's a little number 2 afterwards. So that tells me I have got 2 potassiums. And then I've got O, which is oxygen, and there's no number after oxygen, so I know I've only got 1 oxygen, okay? On the periodic table, the mass of a potassium is 39, so I'm getting that from the periodic table. The mass of an oxygen is 16. So there's 2 numbers next to every element on the periodic table. And you see here, K, potassium, the big number, which is the mass number, is 39. And for oxygen, the big number, which is the mass number, is 16. Although typically they do give you this information in the question. Okay, so this is the mass of 1 potassium. This is the mass of 1 oxygen. But when I read my formula, I see I've got 2 potassiums and 1 oxygen. So my relative formula mass is going to be 39 plus 39 plus 16. Okay, so I've got 2 39s because I've got 2 potassiums. I've only got 1 16 because I've only got 1 oxygen. And 39 times 2 plus 16, my formula mass is 94. Okay, if I do a different one, if I do H2SO4, okay, I've got a 2 after the H. That tells me I have got 2 hydrogens. I've got nothing after the S, so I've only got 1 sulfur. And I've got a 4 after the O, which tells me I have got 4 oxygens. Okay, looking at the periodic table, the big number next to hydrogen is 1. The big number next to sulfur is 32. The big number next to oxygen is 16. But again, they'll typically give you those numbers, all right? When I'm adding them up, okay, I've got 2 hydrogens, so it's going to be 1 plus 1. I've only got 1 sulfur, so it's going to be 32. And then I've got 4 oxygens, so I can do 16 times 4, or write 16 plus 16 plus 16 plus 16. Okay, so this 1 plus 1 is for the hydrogens, 2 hydrogens, so I've got 2 1s. This 32 stands for the sulfur. And then the 4 times 16 is because you've got 4 oxygens, okay? And you add all that up together, and I'm pretty sure you get 98. 16 times 4 plus 32 plus 2 is 98, okay? That's relative formula mass. It's really important you can calculate it. If you can't, you're not going to be able to use the moles formula. If you struggle with formula mass and think you need more practice, then there is another video that I can direct you to, one of my year 9 videos. But have a go at just these questions. So this is page 20 of your core revision booklet. Okay, I've asked you to calculate the relative formula mass of 5 different things, okay, including H2SO4, which I've just done for you. So do those 5 for yourself. So press pause here, do those 5 questions, and then press play when you're ready to see the answers. Okay, so I have included the answers for you on the next page. You'll see Cl2, the big number next to chlorine, is 35.5, and you've got 2 of them, which gives you a formula mass of 71. CO2, 112 for carbon, but 2 16s for the 2 oxygens. Then I have the H2SO4, which I've just done for you. Then it was NaOH, 23 for Na, 16 for O, 1 for H, gives you 40 in total. And then the last one is a little bit harder because you've got brackets in there, okay? The magnesium is outside the bracket, so I do not multiply it by 2. That means I've only got 1 magnesium. The oxygen is inside the bracket, so I do multiply it by 2. I've got 2 oxygens. The hydrogen's inside the bracket, so I do multiply by 2. I've got 2 hydrogens. So the bracket means multiply just like it would in maths, okay? So that means you've got 1 magnesium, which is 24, 2 oxygens, so it's 16 times 2, 2 hydrogens, so it's 1 times 2, and that gives you a total mass, formula mass of 58, okay? If you are getting those wrong or you're still not feeling particularly confident, go on to my press pause and go in my YouTube channel, in my year 9 videos, you'll find a full video just on relative formula mass, which goes through loads and loads of examples. So if you're struggling, go and watch that. And if you can't find it, message me and I'll send you the link. But it's really important you can do relative formula mass. All right. After relative formula mass, we're going to have a look at moles. So there's only one formula triangle that you need to know. Relative formula mass, moles, and mass. So this is your formula triangle. It's the only triangle you need. Make sure you know it, okay? From my formula triangle, I can get the following formulas, okay? If I want to find mass, I cover mass, and I see I'm left with moles times formula mass. So if I'm asked for mass, it's going to be moles times formula mass. If I'm asked to find moles, I cover moles, and I see it's mass divided by formula mass. Mass divided by formula mass. Okay, so these are the two formulas that you're going to be using in your mole questions. I get them both from my triangle. Make sure you know them. All right. So a typical question, they give you mass. They'd want you to calculate M or yourself from your periodic table, and then you would find moles. So they could say, how many moles, actually what one did I do my thing? How many moles in 200 grams of K2O. Okay, so my formula, I'm asked to find moles. So I need my formula for moles. And from my formula triangle, I see moles equals mass divided by formula mass. Okay, in the question, I'm only given one number, 200G. The G stands for grams, and gram is a unit of mass. So that 200G is the mass. So I can fill that mass straight into my equation. I need to divide by the formula mass. Okay, the formula mass you would have to work out using the numbers from the periodic table. We've already done K2O above. Okay, we saw potassium, the big number was 39, oxygen was 16, and we worked the formula mass out as being 94. So it's going to be 200 divided by 94. Oh, I've done this already. Is 2.13. And that's how many moles are in 200 grams of K2O. So they give you a mass, you find the formula mass, just like you did in part 1, you divide, and you're going to find your number of moles. Okay. The other thing they can ask you to do is ask you for the mass. So they could say, what's the mass of 3 moles of CO2? Okay. Formula for mass, okay, from my triangle is moles times formula mass. Okay, in my question, I'm given 3 moles, so I can fill 3 in for moles straight away. And then I need to multiply by my formula mass. This I can work out by looking at my periodic table. The big number next to carbon is 12. The big number next to oxygen is 16, and I've got 2 of them. And I add that all up, and I get 44. So it becomes 3 times 44. Which equals 132. And because it's mass, I'm going to give it the unit of grams. Okay, so this is the triangle you need to know. These are the 2 equations you need from that triangle. And I want you to just practice doing those little calculations. So if you do questions 7, 8, 9, and 10. Okay, so just press pause, 6, 7, 8, 9, and 10. Do questions 6 to 10, press pause, do the questions, and then press play. Okay, so again, I have included the answers for you here, so you can just check them. In 6, I give you 30 grams, and then you divide by the formula mass of sodium, which is 23, and you should get 1.3 moles. The next, you've got 12 grams. You work out the formula mass. You see it's 58.5, so you're getting 0.21 moles. Then I give you 42 grams. The formula mass works out as 100. 42 divided by 100 is 0.42 moles. In 9 and 10, I ask you for mass instead. So I say you've got 3.2 moles. You multiply by that formula mass, which works out as 56, and you get your answer in grams. In 10, you only have 0.8 moles. You multiply that by the formula mass, which works out as 111, and you get 88.8 grams. Okay. Again, if you are having trouble with that, I have got a video in my year 9 playlist, lesson 2 on moles, goes through loads and loads of examples of those calculations. So if you're still struggling with any of those calculations, watch those videos instead. Find me if you don't have the links. Okay. The next thing that we're going to do, okay, we've looked at how to calculate moles, but we haven't looked really at what moles are. Okay, so when we calculated there, we calculated that in 200 grams, if you had 200 grams of K2O, we worked out that 200 grams of K2O meant you had 2.13 moles. But what exactly does that mean? Okay, moles, that word mole represents a number, and the number it represents is 6.02 by 10 to the 23. So if you've worked out that you've got 2.13 moles, then you've got 2.13 multiplied by 6.2 by 0 to 10 to the 23. You can work out how many individual atoms you've got. Actually, this is an ionic compound, so you're going to be talking about ions, but we won't worry about that. So 2.13, okay, this is how I'm going to do it with my calculator. 2.13 multiplied by, actually you can't see any of my buttons, but anyway, 6.02, and then I've got a little button down here, which I press and I get a by 10, and then I do to the 23. And I punch that in, and I realize I got 1.28 by 10 to the 24, and that's the number of ions that I would have in K2O. I'm saying ions because potassium oxide is an ionic compound, so the individual particles you're going to find in there are going to be ions, okay? So I know I've got this many moles. I know that mole represents this number, so I put this number in for the word mole, I multiply, and I work out the number of ions in this case, okay? So these calculations, what you're going to notice with them is that it doesn't matter which chemical they're asking you about, the calculation isn't going to change, okay? So I had 2.13 moles of potassium oxide. If I had 2.13 moles of iron, okay, just 2.13 moles of iron, and I wanted to know how many atoms I had, I would still take my 2.13, I would still multiply it by this number because this number represents the word mole, and I would get exactly the same answer. So it doesn't matter that I'm talking about potassium oxide up here and iron down here. If I've got the same number of moles, then my calculation is going to be exactly the same, and I'm going to get the same answer, okay? It'd be the equivalent of me saying, how many socks do you have in 4 pairs of socks? Okay, if you had 4 pairs of socks, you would have 8 individual socks. You do 4 times 2 is 8. If I asked you how many shoes you had in 4 pairs of shoes, you would still do 4 times 2 is 8 individual shoes. So it doesn't matter that you've gone from shoes to socks. The calculation for 4 pairs is going to be exactly the same no matter what you're talking about. And it's the same with your elements and your chemicals. If you've got 2.13 moles of something, it doesn't matter what it is, it's always going to be 2.13 multiplied by this number. Okay, the calculation is not going to change. And that will tell you, in this case, the number of atoms you've got in 2.13 moles of iron. Because potassium oxide is an ionic compound, I would say that they were ions. That's how many ions you've got. But basically, it will tell you how many small individual particles that you have got in your substance, and the calculation is always going to be the same. So I'm going to get you to I only get you to do 2 examples of these because the calculation is exactly the same. I ask you for how many atoms are in 3 moles of sodium and how many atoms are in 4 moles of carbon. So just do both of those calculations. You will need a scientific calculator. Do them for yourself, press pause, do them, and then check your answers. Okay, so for 11, you had 3 moles, so I'm just 3 multiplied by that number that moles represents, and this is my answer. The next one, 4 moles of carbon. It doesn't matter that I'm going from sodium to carbon. That does not affect the calculation. It's just 4 multiplied by that number, and it gives me the number of atoms in carbon. Okay, so obviously you will need a scientific calculator to do these calculations. I know at the time when we were doing this, a lot of you would get confused about when you were supposed to use this big number. A general rule, if they give you this number in the question, then they want you to use it, okay? And there's kind of 2 types of questions that you'll use it in. The ones we've just looked at is when you are trying to calculate the number of atoms in something, the number of atoms in something, or the number of molecules in something, or the number of ions in something, depending on what that substance is. Okay, it doesn't matter if they ask you for a number of atoms or a number of molecules or a number of ions, you're going to do the same thing. You're going to take the number of moles and you're going to multiply it by 6.02 by 10 to the 23, okay? Number of moles, they'll either give you the moles in the question, or they could give you the mass. You have to find the moles, and then you'd multiply by this number, okay? But a clue that this is what they want you to do is when they give you this number in the question, they'll want you to use it. So you find the number of moles, you multiply by this number, and that will give you the number of atoms, the number of molecules, the number of ions, whatever it is that you are being asked about, okay? There is one other way that they can kind of ask this question, and one other type of question where they want you to use this number, okay? And we're just going to have a look at moles in slightly more detail. We never really spoke about why this number was this number. So if we look at carbon for an example, okay? Carbon on the periodic table, it has a big number of 12 and a small number of 6. Okay, so let's say, for example, I had 1 mole of carbon. Okay, if I had 1 mole of carbon and I wanted to find out the mass of 1 mole of carbon. Okay, so I want to know what's the mass when I have 1 mole of carbon. Okay, so I know my formula for mass is moles times formula mass. Because I'm just talking about 1 mole, I'm going to fill in 1 for moles, and the formula mass of carbon is 12. So I work that out and I get 12 grams. So if I've got 1 mole of carbon, I have 12 grams of carbon. Okay, and that number 12 obviously matches the big number that you have got in your periodic table. Okay, it would be the same for what's the mass if you had 1 mole of sodium? Okay, sodium has a big number of 23. So if I want to find the mass, it's going to be 1 times 23 is going to be 23 grams. So those big numbers on the periodic table, okay, they tell you the mass of 1 mole of that element. So if I had 1 mole of lithium, it would have a mass of 7 grams. If I had 1 mole of magnesium, it would have a mass of 24 grams. If I had 1 mole of silicon, it would have a mass of 28 grams. If I had 1 mole of hydrogen, it would have a mass of 1 gram. Okay, so remember, mole is just a number. So what I'm telling you, if you had 6.02 by 10 to the 23 atoms of carbon, they would have a mass of 12 grams. If you had that same number of atoms of sodium, so 6.02 by 10 to the 23 atoms of sodium, sodium is heavier than carbon. So if you have the same number of atoms, the mass is going to be greater. Okay, same down here. If you had 1 mole of bromine, okay, that means you've got 6.02 by 10 to the 23 atoms of bromine. Each bromine is much, much heavier than carbon. So if you've got the same number of atoms of both of them, the total mass of a mole of bromine is going to be 80 grams, whereas the total mass of a mole of carbon is going to be 12 grams, okay? Again, it'd be like if I said to you, if you had a pair of shoes and a pair of socks, okay? A pair of shoes is 2 shoes, a pair of socks is 2 socks, but they don't have the same mass. Shoes are heavier than socks, so your pair of shoes is going to have a greater mass than your pair of socks. It's the same with your elements, okay? 1 mole of carbon has a greater mass, a smaller mass than 1 mole of sodium, because carbon, each individual carbon atom is lighter than an individual sodium atom, okay? So the way they can ask this question is they can ask you to work out they can ask you to work out the mass in grams of an individual atom, okay? So they can ask you, what is the mass in grams of a carbon atom? Okay, and what we know, that if you have got 12 grams of carbon, okay, you have 6.02 by 10 to the 23 atoms of carbon. Okay, because 12 grams is 1 mole, and 1 mole is 6.02 by 10 to the 23. So if you've got 12 grams of carbon, you have 6.02 by 10 to the 23 individual atoms. They want to know what is the mass of one atom. So you would have to take your 12 grams and divide it by 6.02 by 10 to the 23 to work out the mass of one carbon atom in grams, divided by 6.02 by 10 to the 23. And you're going to get a teeny tiny little number, 1.99 by 10 to the minus 23 grams. Okay, so a tiny little number. All right. If you were asked to work out in grams the mass of one sodium atom, okay, I know that 23 grams of sodium, if I had 23 grams of sodium, I would have this amount of atoms. If I want to find one, I would take my 23 and divide by 6.02 by 10 to the 23. 23 divided by 6.02 by 10 to the 23 equals 3.82 by 10 to the minus 23. Okay, that minus 23 obviously means you've got loads and loads of zeros in front of this number. So it's a tiny little number. Okay, so if you're asked for the mass in grams of one individual atom, okay, essentially what you're doing is taking the big number from the periodic table and dividing by 6.02 by 10 to the 23. I'm just going to give you two to do for yourself. If you were asked, what's the mass in grams of an oxygen atom? Okay, what's the mass in grams of an oxygen atom? Big number next to oxygen is 16. Okay, press pause, do that for yourself. Okay, so you take the big number next to oxygen, which is 16, okay, because 1 mole of oxygen has a mass of 16 grams. So if you had 6.02 by 10 to the 23 atoms of oxygen, they would have a combined mass of 16 grams. I want to know what the mass of one individual oxygen atom is. So I take that total mass 16, I divide it by 6.02 by 10 to 23, and I get the mass of an individual oxygen atom is 2.66 by 10 to the minus 23. Okay, so that is how you would do those questions. Again, a clue that you're kind of be using this number is when they give you this number in the question, they want you to use it. They'll either ask you for kind of the number of atoms and you're taking the number of moles and multiplying it by this number, or they'll ask you for the mass in grams of an atom. You will take the big number from the periodic table and you will divide by this number to work out the mass in grams of an individual atom. This video is already starting to get a little bit long and I haven't even looked at moles tables yet, so I'm going to make a second video. So this is video 1 on moles. Watch the next video where I will do the moles tables, I will do concentration, and I will do empirical formula. So watch the next video for the other 3 types of question.